Hello everyone, hello London Video Tech, and hello everyone around the world who's joining for this mega meetup. I'm really glad to be part of it. So my name is Roderick Hodgson. I am here wearing many hats. First of all, I'm the co-founder of Amber Video. Amber Video is a startup that myself and Shamir Alibi started to really address the threat of deepfakes by creating what we call a truth layer for video. In fact, you might have heard me speak about this problem space before, as I've given a few different talks about the subject. Here's one of them, right? And one of the other hats I wear is I'm also the CTO of Simon Says, which is a company that builds tools for video professionals to transcribe, translate, and caption with AI. So there I've been working to make sure that we build tools that really integrate well with video professionals' workflow, and also ensuring that our infrastructure scales well for the hundreds of thousands of media files that we process and transcribe, as well as to serve the tens of thousands of users who rely on our services. But this talk is not about either of those companies. This talk is about something of an adventure that we've been on with our team. One that coincidentally kind of ties my other two areas of work together in quite a nice way. So before we start, let me just give you a little bit of background about myself. So my background is in artificial intelligence. I studied it at the University of Edinburgh, where I graduated a little over a decade ago now. But video has always been really an area of passion for me. When I graduated, I joined the BBC's R&D department, where I was a technologist for the best part of 4 years. And then I decided I really wanted to move into the world of startups. So I worked for a number of different video and comms related startups, which is where I've been ever since. So I guess you can say over the past decade, I've really tried to build neat things that combine video and AI. So let me take you back to about a year ago. So as I mentioned, I've been working tackling deepfakes around the video. That was a key area of work for me last year. Really around this time last year or last summer, we had just trained a neural network to detect deepfake videos. And this was pretty simple, really. We took a image classifying model, well, that's Phil messaging me saying he needs this video, so there we go. So we made we took an existing image classifier, ResNet, which is trained to classify, saying, oh, this is a picture of a dog, this is a picture of a cat, this is the picture of a human. And then we trained it further by showing it, fake videos and authentic videos, and saying this is a fake human, this is an authentic human, and trained it on the basis of that and got very good results. We found in our lab test that we had sort of in the high 99 percentile when we tested on the output of some of the standard, off-the-shelf deepfake libraries that you can, the open source libraries that you can find online. So we thought, why don't we create a Twitter bot so that anyone on Twitter can reply to a video tagging Amber VidBot, and then we'll go off and try and determine if the video is a potential deepfake. Turns out that was much harder than it sounds. It was pretty painful. Of course, there was the process of writing the bot itself and all of its logic for its interaction with the users. But there was also quite a lot of work in, well, first we had to get it to fire off an event to a service that would download the video from YouTube or Twitter and so on and store it into an S3 bucket. Then there was another service that would have to get that video, turn it into a bunch of, a series of stills. And then we'd fire off a whole bunch of events, one for each still, so we could run the next process in parallel, which was, classifying each still, whether it was authentic or fake. And then we had to wait for all of those to be completed and then collate all of that information, all the output from the classifier, and then generate some sort of report that would make sense for a user in terms of, oh, this bit of the video is faked, this percentage of the video is fake, this is how likely I think it is to be faked, and sort of create all of these calculations and present it in a way that was user-friendly. And then we had to hope that none of these steps would fail, because invariantly they would. And sometimes we'd hit limits with the YouTube API, sometimes we would find the files didn't transfer properly from between AWS and Google, moving it from one cloud to another, which we had to do because we decided to run the compute instance, the GPU classifiers on Google, so we had some promotional credit for GPU instances, but we wanted to have the media files stored on S3. So there's all these complications, all these potential opportunities for errors along the way. And we needed to find a way of monitoring those and making sure that we could report back to the users so they wouldn't just be waiting indefinitely for a result that would never come. So that took a lot of work. I think if I was to summarize it into the three main challenges, I would say it would be learning and building the interactions with all the third-party APIs we had to interact with. It was building all these microservices that did these tiny things and making sure that they stayed healthy, we could monitor them, that then we could deploy them when we need updates and so on. And then there was the issue of handling error cases and how we monitored problems along this sort of pipeline. But eventually we built it. And yeah, it took way longer than we thought it would. It always does. And in the end, we didn't even launch it. The reason why is because ultimately we couldn't get reliable enough results when we tested it. When we finally tested it the way we expected users to test it. So we thought, well, users are going to test it with known fakes, the ones that are being shared online. And we trained our classifier on the output of sort of the off-the-shelf deepfake libraries, whilst the popular fakes, the ones that have been shared online, have got quite a lot, heavy post-processing, heavy editing, manual editing involved. And so a lot of the sort of the cues that the AI was picking up on would suddenly be missing from these videos. So we'd get a lot of false negatives with these kind of professional grade deepfakes. And then we also found we got a lot of false positives as well, because we were training the AI on the videos that we had encoded, and we gave it these encoded videos to make sure that it was normalizing for H.264 generated artifacts. But obviously, when we then tried it with videos that had been hosted on YouTube, the accuracy fell quite dramatically, because there were other types of artifacts that the AI hadn't necessarily encountered, or that might have correlated with something that is related or avoided with a deepfake. And so our results using videos that had been uploaded through Twitter or through YouTube were nowhere near the sort of lab results that we were getting. So I mean, if you've heard our story, you'll know that we shifted our focus away from this detection approach towards authenticating video using a special type of fingerprinting that is invariant to certain limited types of editing and storing those fingerprints on an Ethereum smart contract. But until then, we ended up, wasting quite a lot of time. And as we all know, in the world of startups, that wasting this kind of time is never a good idea. And so we thought, well, there's got to be a better way to prototype ideas around video technology and video workflows. And so we thought, could we build a flow-based development tool which had components that were specifically built for handling video files, video streams, video data ancillary to the video files, subtitle data, metadata, and so on, especially designed for that data format, and that was specifically designed for calling video platform APIs and some of the tools and solutions and services focused around video. So that's what we did. This is AV Flow, what we built. It's a tool that lets you drag and drop components to wire together video tools, services, APIs, and so on. As a tool, it's entirely serverless, and it has been built to be highly resilient. So how does this work? Well, essentially, we've got serverless functions for each one of these little components. And we have one other serverless function, which we call the Orchestrator Function. And what we do is we allow the user to set up flows connecting these different components to each other, providing their API credentials where those are needed. We save these flows to a database. We also save their credentials encrypted at rest into a database. And then when a trigger starts a flow, it starts the orchestrator function, which then looks up the flow in the database, creates a new run for the flow, and it goes and gets provides the data and calls the next serverless function in that flow. It then also instructs that serverless function to call the orchestrator function when it's done. So it always bounces back to the orchestrator. The orchestrator then, when it gets called again with a result, can look at the next step of the flow and then call the next function with the new data it has, updating the database as it goes along, and saving logs to the database. So kind of something like this. So there's a trigger that sets up the orchestrator, and the orchestrator pings back and forth all these different services, one after the other, storing the output along the way. So what does that look like? Let's try for a quick demo, shall we? So this is the AV Flow dashboard. So I'll start a new flow. And I was having to think about what we could build for this. So I had one idea of something we could build, which should demonstrate this quite nicely. I don't know if you've seen sort of the trend over the last few months or even maybe the last year or so, of Instagram users posting Insta stories with subtitles burnt in directly to the video, often using quite nice text effects. The idea being, beyond just accessibility, I think the idea was also that if users are consuming their Insta stories without using sound, without having headphones plugged in, or in public transit and so on, that they're able to follow what's being discussed and are shown this text overlay, which are essentially subtitles but as a text overlay on the video. So let's see if we can build a service for those kind of users in AV Flow, and let's see how long that takes us. So we can imagine for the service we'll have, we can imagine it being an app, for example, that records a video on the user's phone and just uploads it to an S3 bucket. So we can use the S3 bucket as a trigger. So on an upload event into this bucket, we will, let me just set up my credentials and the bucket name. Let's use this bucket, shall we? Perfect. And we'll use the input folder. Okay, so that set up our trigger. And so now when that starts, it'll launch the orchestrator, and the orchestrator will use the S3 URL, which is the data it gets from this trigger, to start the next step in the process. So our next step, I think we can straight away transcribe the speech from the audio of that video. So we can use as source our S3 URL and save it to that same bucket. Okay, then let's generate a subtitle from the transcript. So we need something like an SRT file. So let's generate that. And our source is the transcription data that we generated and uploaded to the bucket. And we will save that also to the bucket. Okay, there we go. So we've got the subtitle, let's burn it in. So let's transcode the video with a text overlay. We will use the original video from the S3 bucket. We will use the subtitle URL from step 2, and we will save it into the same bucket. Why not? And yeah, we've got our burnt in video file. Let's upload it to Mux as well. So let's get the burnt in video and the token. There we go. Okay, and let's set up a webhook. Let's get it to query an API when it's ready with all the data that we want. So we'll do a get method, just put a random authentication string for now. And let's set up ngrok. Yeah, that'll do. Okay, so that we have a quick little API we can query with. Let's get it to send some JSON. There we go. Okay. Let's make it live. Okay, we're live. All right, let's copy a file onto S3. This will do the trick. Check it's done it. Okay, perfect. So we've this should have triggered the job. So we'll check in with it in a minute. In the meantime, let's maybe set up another flow just as a quick example. Another quick example. What can we do? Let's set up a web service instead, an API. So this is set up an API for us. This is the endpoint. And we need the user to use our endpoint to specify some data. So let's get them to provide a video URL. You can see, any other types of data we can require, and then pass on to our next functions. But I think we just need the video URL, and let's get it to tweet that video. Let's get it to generate an animated GIF first, so we can use Mux to do that. Use my Mux credentials. Okay, and then we'll get it to tweet that out. We'll get it to tweet the thumbnail and embed the video that came out of Mux as the embedded directly in the tweet. There we go. Okay, so another example. It really is sort of that quick to set it up. You can use a bunch of different components. We've got triggers. We got media download options. So you can download files from Twitter or YouTube. You can email the results. You can run a generic FFmpeg transcoder with whatever parameters you might want. You can use media converter. You can upload to YouTube, you can send it over to Twitter, and so on. So let's have a quick look at our existing workflow and see how it's doing. So let's see, it's processing, so it still hasn't generated the transcript. So we'll have to give it a little bit more time, and then we'll check in with it again in a moment. In the meantime, let's just carry on with our presentation. So, and I suppose just to be clear, well, for me, at least, this is a really interesting playground, first and foremost, for some of the other work I'm doing. So, for example, with Amber, I could imagine we can add an authentication step in AV Flow to fingerprint a video and store those fingerprints on an Ethereum smart contract. So we could add that as one of the nodes in AV Flow. With Simon Says, I think I could do some really interesting things by bringing in some more text processing nodes. So we've got the transcript now. So with some of the innovations that have been happening with natural language processing, with things like GPT-3, etc., I'm sure I could do some really interesting things with the transcript and sort of send that out alongside the video to other platforms and create some other really cool sort of output based on that. But the thing is that it's not just like a toy, it's not just something for prototyping. The idea is that you can build something quickly and then get it in front of your users immediately. We're really focused on doing something that's highly resilient. And the goal was never to completely remove coding from the equation when you're building products around video, but really just to remove some of the most frustrating parts, so that video engineers, video developers, such as yourselves, can test their hypotheses faster by focusing your development time more on the hypothesis, more on the thing you want to test out, the thing you want to prove, and less on wiring things together and handling error cases and making sure it scales for whatever number of users are going to try it. So that's really what we set out to build, and making it highly resilient in this way was very much maybe one of the biggest challenges. Now, failures can happen. We can imagine failures in one of the steps in the flow failing, happening because maybe you've exceeded your quota, or your token has expired. And so now we have this orchestrator that monitors this and is able to handle these error cases. So that's sort of how we handle the errors that might be happening in these sort of third-party services and these components. But there was a much harder problem we had to deal with, which was what happens if the orchestration function fails, if the region in which it's running in AWS goes down or is unavailable for some reason, then all of our state management kind of flies out the window. So to address this, we deployed the function in as many different regions as we could, and we have the functions monitoring the health of the other functions in the other regions, and they're able to take over from each other if one of them is not responding to particular triggers. If it detects that one is down, it will take over. And because we're storing all the state in AWS DynamoDB and we're using global tables, then it always has the latest and correct version of the flow that has been built. And so if either DynamoDB or the orchestration script is not operational in that particular region, then if another region takes over, it's able to use its own local copy of the database and is able to take over entirely without any impact and with it being completely invisible to the user. So that's what we built, and this is actually the first time we've shown it off in any kind of public setting. So there's really three things I want to leave you with, and I would really, really love to hear from you all. So the first thing is, what you think you might be able to build with these tools, how it could fit into some of your existing development processes and workflows. I'd really love to hear what you think we should add in order to make it work better for you, and would love to hear from you if you'd like to try it out, because we're going to be launching a private beta in the coming week or so. Please drop us a line, hello@avflow.io. We'll 100% be on the other end of that inbox. We really want to hear from all of you what you think, how you might use it, and if you'd like to try it out. And I'll be available for questions. And so look forward to hearing from you all, whether that's in the questions or by email. So thank you very much.